Okay, here we go. Yeah, I want to do another video because I may have misspoken a little bit regarding special relativity, but I double checked just to make sure. And the effect is the exact same thing with general relativity, only with speed. Now they have this thing called acceleration, where it's not it's not exactly our definition of acceleration. You know, when you get a car, you accelerate, you feel the G's. That's not what they mean in physics. In physics, what they mean is that you're moving. In general relativity, you're quote unquote accelerating towards the black hole. You're moving towards the black hole. In special relativity, it's quote unquote acceleration, but it's a constant speed, so it's not actually acceleration, but that's what they call it. Moving at the speed of light, which has the same effect as slowing down time and contracting distance. But in general relativity is the exact same thing. That's the what do you call it, epiphany that Einstein had. It's the same effect as the two opposite extremes or two different causes. Of course, we can't move at the speed of light. We don't move at the speed of light. Uh, in quantum physics, there's no locality. There's an approximate locality or something, but in our fabrication of limited time and distance, we are either in one place or another. But in quantum physics, that's not the case because everything's at the speed of light, where there is, where it takes no time to travel no distance because there's everything is, how do you say, there's no locality? Yeah, there's no locality in quantum physics. But of course, we exist in a locality. We're either somewhere or one place or another because we exist in the dilated time or contracted distance and time that's slowed down so that physical things can take place, physical matter can exist, which we consist of, and on a macro level, where there's a location. We're either in one place or another. Anyway, back to what I was my observations of general relativity is that regarding the redshift, what we're probably seeing is um, we're seeing the light from the center of the galaxies. Distant galaxies, we're seeing more of the light of the center of the galaxies because that's the light that's going to be reaching us because light from individual stars are likely not reaching us as well. But there is light reaching us, probably from more the center of the galaxies, which we're not. We're close to the center, but we're not at the center. So what happens is, as light leaves a galaxy, it's redshifted. When light enters the galaxy, it's blue shifted. So it'd be basically the same thing, right? So however much light is redshifted, it's going to be blue shifted back to the original spectrum, unless it came from a place closer to the center of the galaxy. Now, the only problem would be is the distance that it's traveling through expanded distance, which is uh, a larger measure of distance. So that could be what's causing the redshift because the farther away it is, more redshift it is. A galaxy twice as far is twice as redshifted. And now James Webb is finding galaxies that are extremely redshifted, except it still can't see light, apparently, unless they haven't told us yet. James Webb hasn't been able to see light from black holes because of how redshifted it would be because of the distance into a singularity black hole. Anyway, I just wanted to clarify that because I think I might have said that in special relativity, time speeds up, but no, it's the exact same effect. Time, as general relativity, time comes to a stop at the speed of light. Comes to a stop because there's no distance at the speed of light either. You're just already there. That's why there's no locality, or there's no one place or another place in quantum physics, is because everything is at the speed of light. So we don't exist at the speed of light. We exist in slowed down time and contracted distance, so that the matter that we consists of like the collapse of the wave function, so that we're either in one place or another. We have locality. We're either here or there, like Dr. Seuss says. But that's not the way it is in quantum physics. That's what's so strange about quantum physics, is that there's no locality, but we exist in locality because of the contracted measures of time and distance, or the slowed down time and the contracted measure of distance. Because sometimes I might misspeak because I have to keep all this stuff straight and then remember it as I'm saying it, because I might be thinking of something else while I'm trying to say it. But I think I got it pretty much right. The only thing is that when light is leaving another galaxy, it's probably leaving from closer to the center of the galaxy than where we are, hence the redshift. Except for the more the distance, probably the more redshifted it is, because it originates from a more contracted measure of distance and travels through an extreme distance of expanded distance, which could be the cause of the redshift. If not, it's just closer to the center of the galaxy. The light that we're seeing is closer to the center of the galaxy. We're closer to the outside edges of the galaxy by comparison, hence the redshift of the light. At any rate, there's no reason to believe the universe is expanding into oblivion, because it doesn't even make sense. There's no inflatons. The vacuum of space is due to the black holes to begin with. The vacuum energy is due to the space-time frames of reference is being dragged into the black hole. It's actually accelerating or moving time and space into the black hole, where we can't see it anymore. We can't see what happens there anymore because light is extremely redshifted. Not even the James Webb telescope can see the light from a black hole because of how redshifted it is, which means, which means that the most distant galaxies that we can see and detect with the James Webb telescope in the infrared spectrum, those distant galaxies are closer to us, literally closer to us, than what is inside of the black hole. Because we can see the redshifted light from, or detect the redshifted light from distant galaxies by way of the James Webb, but we cannot see the light that's redshifted from inside of the black hole. Because light coming out is redshifted, light going in is blue shifted. So that's about wraps it up. Thanks for everybody's participation in my videos and interest and etc. And God bless everybody. Take care and stay close to the truth so that you keep your sanity. And I say that tongue in cheek.